Okay, so let's start it. 1.2 is about estimation, graphs, and mathematical models. In this session, we have 24 questions. Let's see if we can get it done within 15 minutes. Let me double check I'm recording the class right here. Yeah, I'm recording it now. Okay, so first question. First question is an addition, just a arithmetic problem. And I would let you to work, do that on your own, okay? Yeah, use your calculator. Yeah, this one is to subtract. When we subtract or add numbers vertically, make sure you align them very well. As you can see, 8 is the ones in the first number, 5 is the ones in the second number. Yeah, all the digits with the same place value are vertically aligned. And number 3 is about multiplication.
We can't see your screen.
No,
you cannot?
sorry.
No.
I already shared. I'm not shared. Let's see. Share application. What about now?
No.
No?
Now, yes.
Yeah, okay, perfect. Sorry about that. Okay, so the first a few questions are about the addition, subtraction, multiplication. This is division. So I would let you to complete those questions on your own, very basic. Number 5, yeah, let's look at number 5. A formula that approximates real-world phenomena is called a model. Hold on. No, it's called a formula that approximates real-world phenomena. Yeah, is a model. Let's see. Yeah, it is a model. Yeah. Next question. Determine whether the statement true or false. The statement says line graphs are often used to illustrate trends over time. That is correct. Yeah. If you are interested in finance, you will see a lot line graphs whose x-axis, the horizontal scales, are time. Yeah, time series graph is one example of line graphs. They are often used to illustrate trends over time. The statement is true. Okay. Next, determine statement true or false. The statement says mathematical modeling results in formulas that give exact values of real-world phenomena over time. That is false. Yeah, mathematical modeling is a very strong, powerful tool, but it cannot give exact values. It can only estimate. Mathematical modeling is one way of estimating. Yeah. In my table note of this section, I introduced 3 ways of estimating. One method is rounding, and another method is so let me check. Do you guys are you guys able to see my table note in the course shell?
I think so. I think they're in the essentials one. I've seen them.
Yeah, it's in the QR class. Yeah, I did not post them in the essential class, but it's in the QR class. Yeah, anyway, 3 ways to estimate. One of them is mathematical modeling. So the statement is false because the formula will introduce values of the variable that do not make sense. The statement is false because model breakdowns occur when it is extended too far into the future. Yeah, it has its scope. It has its scope. So this is false because exact value is too extreme. So we choose false, and this would be the correct answer. One purpose of modeling is to predict, but it has a scope. If it's far away in the future, far into the future, it's gonna, will not apply. So we choose the last answer. Number 8. According to a survey, this many people can speak a language other than their native language. Round this number to the nearest. A is hundredth, B 1,000, C 10,000, 10,000, D 100,000, E million after me. Okay, so this is to round a whole number. Part A is to round the nearest 100. Nearest 100, this is ones. This is 100, right? And then there's a ones, tens. This is 100. This 6 to the right of this comma. So we're gonna copy 17,272,700. Yeah, we're gonna round it up. Yeah, anyone can explain why we need to round it up? Because the rounding will take place at this 6, the first 6. But we look at the value, the digit to the right next to the rounding place. If that digit is bigger than or equal to 5, we rounded it up. We rounded it up. Yeah, since this 6 is bigger than 5, we rounded up. So 6 is gonna become 7. So 65 is gonna round up to 100. And now 100 add on top of the 600 gives us 700. Does that make sense? Is the basic rounding rule. Basic rounding rule. Part B is to round to the nearest 1,000. It's hard for me to pronounce. 1,000. Okay, so this is ones, tens, hundred. This is thousand. This is 2. 2 here is 1,000. 1,000. So we look at the digit to the right of the 2 is 6. 6 is bigger than 5, so we round it up again. It means we are going to round 665 up to 1,000, and now 1,000 add on top of this 2,000 gives us 3,000. So we're gonna copy 273. Yeah, it was 272,000, right? And blah blah. But now we round it up, so we're gonna have 273,000. You can rewatch the video. I will have to go over a little bit faster because we have 24 questions to complete it within 15 minutes. Averagely speaking, 2 minutes, 1 question. Part C, and this question has so many parts. We're going to round the number to the 10,000s. So ones, tens, hundreds, thousands. This is 7, right? Yeah, 7. So we look at the digit to the right of the 7, which is 2. 2 is less than 5. In this case, we're going to round it down. How do we round it down? We're going to change, we're going to get rid of or just ignore the 2,665. We're going to change them all to zeros. So we have 17 million. This time, let me type the comma. Let's see if the system recognizes as correct. So 17 million, 270. We are going to round it down, right? Yeah, 270,000. 1, 2, 3, like that. So from 2, 2, 6, 6, 5, the last 4 numbers, we're going to change them to zeros because we are rounded down. Yeah, still correct. With the comma, without the comma, the system will recognize. So when we practice, one purpose is, get familiar with the system. All the questions in quizzes and all the questions in your tests, those are super, super important. If you can pass or not, you can get A or B or C or D. Depends on the quizzes and the tests. Good thing is those questions you see in quizzes and the tests are similar with the questions you see in the homework. They are from the same pool, same bank. Part D, we are going to round it to the nearest 100,000. So earlier is 10,000. So now it's 100,000. So it's 7, right? It's 7. Hold on. So 1, 10, 100, 1,000, 10,000. 100,000 is this 2. This 2, 100,000. So this 2. And since the 7 next to the 2 is bigger than 5, this time we're going to round it up. So 17 million. With the comma can help us to think, right? We're gonna round 72,665 up to 100,000. So add that on top of 200,000, we have 300,000, right? With the comma help us to organize those numbers. And this time round to the nearest million. Million is this 7. This is 7. Okay? Since the digit to the right of 7 is 2, we are going to round it down. When we round down a whole number, that means we are going to change all those digits to 0. So just ignore them. 17 million. 1, 2, 3. 1, 2, 3. Be careful. I meant to type in comma, so do not accidentally type in a dot. If you enter a dot, then that becomes decimal, right? Is a comma. Be careful with that. F rounded to the nearest 10 million. So original number is 17,272,665. 10 million is 1. Since 7 is bigger than 5, we're going to round it up. So 17 million, we're going to round it up to 20 million. 20, 1, 2, 3, 1, 2, 3, 6 zeros give us a million, so 20 million. Very good. And that's that. A little bit time consuming, but it's a good question. This question is a decimal. We are going to round this decimal to the nearest 100,000th. 100,000th. Okay, you tell me please, guys, which digit is the digit we are going to round the decimal at? Which digit has the value place value 100,000th? It's hard for me to pronounce. This is a tens, this is a hundreds, thousandth, 10,000th, 100,000th. You guys tell me, please. Which digit we are going to round the number at, the decimal at? Hello? Hello? Let's see the chat.
The 0?
3. Lane is correct. Is 3. Let's go back. Let's see why is 3. So this 6, the number. Let me see if I can make this bigger. It's pretty small for me as well. So it's decimal, right? 2.650235554. I have the note, and actually I just noticed that the video I posted about the 1.2 has no sound, so I'm going to make a new one to replace that one. I accidentally muted myself when I record a video. Do you guys see this table? Decimal place value chart. Yeah. So the pink part is the decimal point, right? The digit right to the right of it is tenths. And then we have a hundredths. And then we have thousandths. And then 10,000ths. And then hundred thousandth. And then 1 millionth. Yeah, we need to study this chart before we work on rounding numbers, right? Yeah. So do you see that? Yeah. Start from tenths, and then hundredths, and then thousandths, and then 10,000ths, 100,000ths. Yeah. With that said, yeah, please help me to do that again. Which digit is the 100,000th? Which one? 3, exactly. 3, right? Yeah. So 3 is where we are going to round the decimal at. But we look at the number to the right of 3, which is 5. Yeah, that number is bigger than or equal to 5. So we round up, we round down, guys.
Up.
Up. Awesome. Yeah, perfect. So when we round a decimal, it's a little bit different from rounding a whole number. This is how do we round a decimal. We're going to round it up, right? So we have 2.6502. Since we rounded it up, the 3 going to become 4, right? And then we do not put the zeros. We are done. Yeah, that's it. Just to get rid of the rest of the digits. So 554, just throw them away. Yeah, ignore them. And the 3 become 4. Is that clear? Yeah, it's the basic rounding rule. You know, rounding is pretty important to this course. In later chapters, you're going to do tons of rounding. Especially test 2, guys. I'm going to give you a heads up. Test 2, if you are not careful, you are going to do really bad. If you are not careful with the rounding, you are going to do very bad. Because the system will only give you the full point when you if you give the system the correct answer with the correct rounding. So be very careful. Yeah, we use the whole section to practice rounding. Number 10, round the two numbers to the nearest 10. An estimate of the sum is, okay, so 348. Anyone can help me to round that number to the nearest 10. This is ones. This is 1. This is 10. What is it?
350.
Awesome. 350. Yeah, exactly. 350. And the second number is 588. Can you help me to round that number to the nearest 10?
590.
590. Awesome. Yeah. And then you add them up. What do you have, guys?
Where's my phone?
94. You have 940, 940? Yeah.
Yes.
Okay, awesome. Perfect. Next. Huh? Oh, same question. Have the second part. The actual sum. Well, actual sum, let's see. What is it? 348 plus 588.
936.
936. Yeah. 936. Yeah. How reasonable is your estimation compared with the actual answer? Well, very reasonable, right? Very close. Yeah. Only a little bit bigger. Yeah, reasonable. The estimate seems a little bit higher compared with the actual answer, and that's it. Very good. 3 parts of that question. In this case, we have a subtraction of decimals. Let's see what we're gonna do. Obtain an estimate for the following computation by rounding the numbers so that the resulting arithmetic can easily be performed by hand or in your head. Okay, this kind of questions, is a little bit challenging because it takes your judgment. It takes your judgment. Last semester, I got a lot of questions about how do I know I should round this? How do I know? So use your judgment. Use a calculator to perform the computation. How reasonable is your estimate when compared to the actual answer? Okay, so the estimate of the difference is by rounding the numbers so that the resulting arrangement can easily be performed by hand. So I would do 33.5. 33.5 minus 12.4. Yeah, the first number I rounded up to the nearest tenth. Second number I rounded down to the nearest tenth. And I think that is good enough for me to quickly get a result. I got a 21.1. Yeah, do you see what I'm saying earlier? Why I said this kind of question is a little bit challenging? Because it doesn't tell you how to round. You have to use your own judgment. And that's another reason we need to practice, right? So if you see the same questions in quiz, if that's the first time you see the question, that is challenging. But since you practiced when you do the homework, so when you see the same type of question in quizzes, and you know how to do that, right? And you only have 3 attempts for quizzes. And if you see the same question in test, and you only have 1 attempt for the test, and you know how to do that because you already practiced. Incorrect. Use the digit in the 10th place to round the given numbers. I did.
It's not a point, it's just 21.
And to the nearest integer. Use the digit in the 10th to round to the nearest integer. Oh, so we want to round it to the integer? Okay, let's do that. So 30, round it down, 33 minus, round it down, 12. And we got a 21. So that's what it means. Oh, my bad. Here we go. So actually, it does tell us what to do because it said type a whole number, right? You know what? We have unlimited times. Yeah. To type a whole number. So that's how do we know we should round both decimals to the nearest whole numbers. Okay, here we go. Yeah. So whatever we have the information in the parentheses, we should pay attention. The actual difference, let's see what's the actual difference. I'm using a calculator, 33.48 minus 12.432. The actual difference is 21.048. 048. Is very reasonable. Is a little bit lower. Reasonable estimate a little bit lower compared with the actual answer. This one. Okay, so next question. Multiplication. I think is similar with earlier. So let's read the sentence in the parentheses. Type an integer or a decimal. Oops. So yeah, that's why we are practicing, right? Obtain an estimate for the computation shown below by rounding the numbers so that the resulting easily be performed by hand or in your head. Okay, so in order to perform that in your head, and we want to as convenient as possible. So I'm going to try 0.8 times 500. 0.8, 80% of 500 is 400. Yeah, I can perform that in my head. So the answer is 400. Type an integer or decimal. I think this is good enough. Yep. The exact value. Okay. So 0.79 times 514. The actual value is 406.06. 406.06. 406.06. It is reasonable and a little bit lower than the actual. The values are how reasonable? The values are approximately equal. Yeah. And this question, we do need to use judgment, right? Yeah. The previous question, actually, the information in the parentheses indicate we need to round it to the nearest integer. But this one, we do need to use judgment. Okay, number 13. Same requirement. Yeah, easily performed by or in your head. Okay, so I want to perform that in my head. And the first number, I'm going to round it to 90, very close to 90, right? And the second number, 5.8, I'm going to round it to 6. 90 divided by 6 is 15, right? Yeah, 15. Type a whole number. Okay, here. Yeah, type a whole number. We do get a whole number by using that rounding. Actual quotient using calculator, 89.88 divided by 5.8. 5.8. The quotient is, 89.88 divided by 5.8. Yeah, round to the 3 decimal places as needed. Yeah, you're gonna have many digits, right? So how do we round it? After we round it, we have a 15 point. Round it up or round it down? 497. Round it up. 497. Yeah, right? Yeah, 496555172. That's what I have. Round it up, we have a 497. Yeah, three decimal places. Our estimation is reasonable, but a little bit lower. This one. And a little bit lower. Next question. Estimate the product. Okay, same requirement. So 27% OF of 419,271. So if you are taking notes, please include this in your notes. You know, when I was at school, when I was in high school, actually, I have a handmade small notebook, very convenient. And we cut it in heart shape or apple shape. And we can, very convenient, so we can put it in our pocket. So I wrote all the formulas and the important things in a note, in a small notebook. And when I have a small time, I can just review those things. And that helped me a lot. So if you have a notebook, write OF here should be translated as multiply. Okay? How do we process? This is given in a sentence, right? Yeah. How do we translate that to algebra? Translate OF as a multiply. So here we are multiplying 27% with 419,271. Okay, question. How do we, yeah, of course, if you have a calculator, 27%, some calculator has a percent sign. You can use that. But what if I want to help me to convert 27% as decimal? Can you help me with that? How do you convert 27% as decimal? What is decimal equivalent?
Divided by 100.
Yeah, so 0.27, right? Yeah, okay. So 27%, not very convenient. So I'm gonna round it to 30%. And that is 0.3, yeah. And then multiply, and that number is so inconvenient. So I'm going to round it down to 400,000. And I should be able to find out the multiplication. 30% of 400,000 give me 120,000. 120,000. 120,000. I can do that in my head. 120. 1, 2, 3. Type an integer. That is an integer. Actual product. It tells you product, right? Yeah. But also it's good to know OF means multiply. So actual product 0.27 times 419,271. Actual product is 113,203. 113,203.17. You have the same thing? Is the estimate reasonably close to the actual product? Yeah, it is pretty close. Are you guys doing well? One thing I do not recommend is you are doing your own homework while we're supposed to doing it together. That's not efficient. You do not multitask when you learn mathematics. So I hope you focus on the questions we are looking at right now and then do your homework after. Okay, so let's see this question number 15. Determine the following estimate without using a calculator. Then use a calculator to perform the calculation necessary to obtain an exact answer. How reasonable? Okay. So estimate the total cost of 6 grocery items if their prices are by rounding each price to the nearest dollar and then adding. Okay, so let's do that. Let's try to do that in our head. Okay, this first one $10 and then $8, so 18. 18 plus 2, 20. 20 plus 7, 27. 27 plus 6, 33. 33 plus 2,
35.
35. Yeah, so the estimation is 35. So if you have your receipt, if you round them like that to the nearest dollar and quickly add them up, you can quickly get the estimation of your cost for the purchase, right? Purchase, yeah. The actual cost. Now I have to use a calculator to do that. 10.06 plus. Can you help me with that this time? I'm waiting for you to give me the answer to see if you are with me. 1.93, 6.69, 6.33, 2.39. Yeah. To have a good score from this course, a good tool, a good calculator could make a huge difference. All right. 35.45. Awesome. Thank you, Lane. Exactly same with mine. 35 point. Again, sometimes I typed wrong. I wanted to type dot. Sometimes I entered a comma. You have to be very careful. They look similar. 35.45. Oops, 45. Yeah, very close. Is a little bit lower than the actual result. Difference is 45 cents. 0.45. You can play with, right? Yeah. You ask, should I enter 0.45, which is 0.45? You try. You have unlimited times. Yeah, you're gonna spend time with the system. Then you know to know the system very well. Then when you take the test, the system will not give you a hard time. Number 16. Determine the following estimate without using a calculator. So a raise of 310,000 is evenly distributed among 303 professors. estimate the amount each professor receives. Okay, so firstly, let's figure out how do we use the two numbers to get the amount of money every professor would receive. Yeah, how do we use these two numbers? We're going to add them together, minus or multiply or divide.
Divide.
Divide, awesome. Yeah, this is the total amount. This is number of professors. So we're going to use the total amount to divide by the number of professors. Then we get the amount for each professor. Okay, but the division is not convenient, right? In order to make it convenient, it rounded to the nearest 1,000 as needed. So this could be a hint, nearest 1,000 as needed. So nearest 1,000 here, but I'm going to make it round this number as 300,000. Just ignore the 10 grand. Ignore the 10 grand. Yeah, just round it down to 300 grand. 300 grand. Yeah, 300K. And the number of professors, I also round the number down. 303, just around 300 professors, right? Yeah. So 300. So 300. Hold on. Yeah, 300 grand divided by 300. Now that is 1 grand for each person, right? 1 grand for each person. And rounded to the nearest 1,000. It is nearest 1,000. Okay. The actual amount, let's see. We use 310,000 to divide it by 303. We're going to round to the decimal to the nearest cent because it's money, right? So round it down. We have, what do you have, guys? Let me see if you're with me. 1,000. How do you round it? Cent. Yeah, the nearest cent. Did it say nearest cent? Round to the nearest cent as needed. 10, right? Do you agree, guys? It doesn't say nearest dollar, nearest cent. All right? Yeah, nearest cent. The estimate is a little bit lower than the actual value, but is very close. The error is only $23.10. 23.10. Yeah. Read the question carefully. We learn this. Why do we need to take this class? And this class is so different from any other math classes because it has so many different contents. And this chapter maybe has nothing to do with the next chapter. Main reason we take this class is to cultivate our math learning ability, to raise our problem solving ability. And those problems involves quantitatives, involves numbers. Let's see number 17. Obtain an estimate using then use the calculator to how reasonable. Okay, so this is what I can see is this number. I'm going to round it up to 0.6. This number 0.6, and this number 0.2. Yeah. So what is 0.6 divided by 0.2? Only look at these two numbers. Numerator has a factor 0.6. Denominator has a factor 0.2. What is it? How many times 20 cents goes into 60 cents?
3.
3, awesome. Yeah. So those two numbers gives us 3 in the numerator, 1 in the denominator. And then 101, just round it down to 100. So 3 times 100, 300. Number 17. Oh, okay, we're not done yet. The actual quotient. Okay, what's the actual quotient? Actual quotient, let's see, 0.59939 times 101 divided by 0.205. Rounded to the decimal places, 2 decimal places. What do you have, guys? You can tell me, you can unmute yourself. 2 decimal places. 295 point what? Hmm? Are you guys with me?
Was it rounding to 2 decimal places?
Yeah, 2 decimal places.
Okay, I got 295.30.
It's 31, right? Because it's 9.
Oh, yeah.
9.
I was
Yeah.
waiting as a 0. Yeah, you're right.
Yeah, exactly. We rounded up 31. Awesome. Very good. Thank you for your participation. Yeah. Okay, so this number 17. Oh, one more. Not done yet. Okay. So the estimate is higher actually this time. Yeah, it's a little bit higher. It is reasonable. The difference is 4.69. 4.69. You just need to use 300 to minus 295.31. Okay. Number 18. Imagine that Amy counted 60 numbers per minute and continued to count non-stop until she reached 10,000. Sorry. Determine a reasonable estimate of the number of hours it would take Amy to complete the counting. So how many hours? How about let's see how many minutes first? Yeah.
Okay. 60 minutes. 60 minutes an hour.
Yeah, 60 minutes 1 hour.
So
Counted 6 numbers per minute.
times 60.
Approximately.
3,600. Oh, so 3?
Let's see. So 3,600. 3,600. Sounds right. Yeah, awesome. Okay, this is about graphs. We have a pie chart, line chart, bar chart. We're going to learn more when we go to later chapters when we learn statistics. Yeah, those are very basic charts. And this is a pie chart. The circle were called the circle graph. It just have different name, but means the same thing. What are we looking for? So shows the most important problems for the 19 million blah blah high school teenagers in a country without using a calculator. Without using calculator. So estimate the number of high school teenagers for whom doing well in school is the most important problem. Okay, let's see. Which color is doing well in school? the blue, right? So how do we understand this number, 90,090,929? What's that number represent?
All of the students in
Yeah,
total?
all the people. Yeah, all the people that did the survey, right? Answer the questions. Exactly. Yeah. Among those people, 11% think doing well at school is the most important thing. So we need to find out how many of those blue people, how many people the blue region represent, right? So 11% off of that. So we're going to use 11% multiply the number, right? But not convenient. So obviously 11% can be rounded down to 10%, 10%, and this 90 million can be rounded up to 20 million. 20 million times 10%. 10% of 20 million is 2 million, right? We don't have 2 million, but we have 1.9 million. Oh, hold on. We don't have 2 million, but yeah, we have 1.9 million. So the closest one is B, right? Yeah, actually the problem intends us to round this number down to 19 million. 10% of 19 million is 1.9 million. Yeah, is either way is B, because all other answers are too far away. Bar chart or bar graphs. This is a multiple bar graph because it has two colors, right? The orange color is a trust in media. The purple color is a trust in government. And the horizontal scale is years. Yeah, and the vertical scale, those numbers are percent. Yeah, it means in 2003, 35% of the population trust in government, 55% trust in media, and then over time, less people trust the media. A little bit go up from 15 to 19, and over time, also less people trust the government. But no bounce up. Basically, less and less people trust anything, right? Government and or media. So what are we trying to do in this case? We are trying to estimate the yearly loss in a percentage of people trusting in government. So let's only look at the purple bar, right? Yeah. The purple bar has a very obvious decreasing. Yeah. The purple bars have an obvious descending trend, less and less. So we are looking for the estimation of the yearly loss in a percentage of people trusting government. Okay, this is a very important question. Very important. If there's anything a little bit challenging, is this one. So this is what we do. Okay, we are going to use the biggest purple, which is 35%. Yeah, let's just use 35 to minus the smallest number, 16. What is 35 minus 16? Don't round them, by the way. Do not round the 35 to 40 and round 16 to 15. Do not round the numbers. Use the information that are. Yeah, yes, 19. Yeah, 35 minus 16 is 19, right? Yeah, and divide that difference by the number of years from 2003 to 2019. How many years that is?
5.
2003 to 2019. How many years?
Oh.
Yeah.
16?
Not by yearly. It's like a 2000, like 4 years. Every 4 years they do the statistics. 16 years, right? Yeah, 16 years. Yeah. So what's the difference against
19.
19? Okay. So we're gonna use 19. That's the 35, the biggest, the purple number. minus the smallest purple number, right? 35 minus 16, which is 19. Divide that by the number of years, 16. Tell me what you have. Let me see if you are with me.
Let me see. 16. 1.1875.
1.1875, right? Yeah, that's the actual number we got. Yeah, you rounded up to 1.19. But let's see, we need to enter percent. Yeah, you know, I had students enter decimal there. But do you see the percent sign here? We need to round it to the percent and then convert to percent and then round it. Round to the nearest tenth as needed. So 1 decimal. So 118.8. 118. 118. It's supposed to be 118.75%, right? But we keep the nearest tenth means keep 1 decimal places. 1 decimal place, so round it up to 8. 118.8%. You see the difference? Yeah, even you got a correct number, 1.19, and you enter, you got it wrong because the cell, the box here is a percent point. It follows a percent sign. We have to take that into consideration. Oops, what happened? Yearly loss in percentage of people trusting in government. 35 minus 16.
1.20.
35 minus 16. Minus 16 is 19 divided by.
It'll be 1.20. If you round it up to the 10th.
Round up to the 10. Round to the nearest tenth as needed.
So the nearest tenth will be 1.20.
This is the 8 is the nearest tenth.
Is it?
Use the information graph to estimate yearly loss in percent of people trusting in government. Choose the percentage used. 10%. 1.2. How do I know the answer? So the phrase yearly loss indicates a rate. The rate is the amount of loss per year. That is the change in the percentage divided by the change in time. We did that. Be sure to round the answer to the nearest tenth. You did. Final check. Oh, it's 1.2. 1.2%. Oh, okay. My bad. A decimal. Oh, okay. I know what went wrong. 35% is 0.35. We should not use 35. We should use 0.35. 0.35. And minus 16%, which is 0.16. So the difference in percentage is 0.19. And divide 0.19 by 16 years. We have 0.011875. And to percent, that is 1.1875%. And rounded up 1.2%. Okay. So we practice, we learn, right? Yeah. So the Those are percentage, so we should use 35%, not instead of 35. Write a mathematical model that estimates the percentage P of people trusting in government X years after 2003. After 2003. So X years after. So we start from 35%, which is 0.35, and then plus X is the P of, not X, P of person in X years. Okay, X years. Our percent, our raise is 1.2%. That is 0.012x. 1.2% plus 0.35. Use integers or decimals for any numbers in the expression. Use the answer from part A to answer this part. 1.2%, part A, the answer from part A is the readout change, the slope. Slope times x plus the intercept. Multiplied by x and then subtract is decreasing, so it's negative. From switch the order. It's decreasing. So P is the percent when x equals 0. Percentage P of people trusting government X years after. Times x when x equals 0 is 2003. When x equals 1 is 0.35 minus 35% minus 1.2%. What's wrong with my answer though? From part A to answer this part. Oh, yeah, very confusing. So this time you use 35 1.2 because it's already percentage. It's already percentage. We're gonna redo this question tomorrow, all right? Which question that is? Question number 20. Yeah, we're gonna redo this question tomorrow. Yeah, your answer is correct because you use the percentage. I converted to decimal, which is not supposed to be like that. Okay, let's remember we're on number 20 and we're gonna redo number 20 tomorrow. Thank you guys for coming. I'll see you tomorrow.
Thank you.
Bye. Thank you.